So let us solve now example or exercise 6.1. The first example is the diameter of a circle is 10 centimeter. Find the length of the arc when corresponding central angle is given as a few angles are given: 144 degree, 45 degrees, 270 degree, 180 degree. Now let us draw this figure once. And this is a sample figure. Okay, the theta is here, this is R, and they have asked us to find something. What they are asked? Find the length of the arc when the diameter is 10 centimeters and central angle, whereas this theta is given as different degrees. What is the length of arc? Theta is given 2 pi r, theta by 360 into 2 pi r. R is given? Yes, but remember that r is given not directly, they are given the diameter. That means you have to first find the radius. Radius is half of the diameter, and you can easily find out the length of arc for different angles. Now in many cases, just remember about this pi. The value of pi is 22 upon 7 or 3.14. Just check in your exam or in that particular problem, have they given the value of pi? If they are given pi is equal to 3.14, you use that. If nothing is given, then according to your simplicity of the solution, you have to use either 22 by 7 or 3.14. Okay, let us go ahead. So here there were 4 different angles were given: 144 degrees, 45 degrees, 270 degrees and 180 degrees. Now one of this question, that is 45 degree question, was appeared in October 12 exam for 2 marks. Extremely easy example for 2 marks. Everything is given, just calculation part is remaining. Let us see the second one. Find the angle subtended at the center by an arc of the following. Now whenever the formulas are given, only one is unknown and you have to find out that unknown. The first, radius of the circle is 5.5 meters. Radius is given. Radius in this formula, radius is given. Length of the arc is 6.05 meters. Length is given, radius is given, only theta is unknown. So in this case, you have to find out the theta. Very easy, only calculation part is there. I'm not going to solve this. Okay, let us go ahead. Before that, in this case, in the first sub question, they have given pi is equal to 22 upon 7. So take 22 upon 7. Generally they are given because by taking 22 upon 7, your calculation parts becomes easy. Whereas in second sub questions, they are given pi is equal to 3.14. That means by taking 3.14, your calculation will become easy. What in the second sub question they are given? Radius of the circle is 20 centimeter and length of the arc is 78.50 centimeters. Now remember only one thing here, only one hitch. They may give the radius in meters or centimeters and length of arc in meters or centimeter. Totally different. One may be in meters, one may be in centimeters. In that case, first you have to bring both the units common. That is the radius and the length of an arc. Both the units should be same. Many students don't understand this. Many students make mistake. They don't read the questions carefully. My suggestion is underline what are given so that you will not miss that. Okay? Unit is the major setback for 90% students. They fail in looking at the units properly. Their method is correct, they know the formula, method is correct, they know all the calculations, but your final answers is wrong. Next, the third is the radius of a circle is 7 centimeter. In this case, the radius is given 7 centimeter. Measure of arc, now in this case the figure is given. Let us see that figure. Let us utilize this figure. the radius of a circle is 7 centimeter. So R is given 7 centimeter. This is example 3. And major arc RYS is equal to 60 degrees. This theta is given as 60 degrees. With the help of the given figure, answer the following questions. Now with the help of this figure, this is 60, this is 7, you have to answer the following questions. First, name the shaded portion. This is the shaded portion they have given. They have given names X, Y, T, S and R. Okay, they are given such names. Now, name the shaded portion. Now there are two sectors always. One is the minor sector, major sector. Okay, what is the name of this sector? This sector name is PRYS. You have to write like this. This is PRYS. This is the minor sector. Then what is the major sector? You can spell the major sector by PRXS. Second sub question they have asked, find the area of the circle. Very easy. You know the radius, pi r square. You know the formula for area of circle, pi r square. Third thing, find the area of PRYS. PRYS. That means they have asked the area of this sector. What is the formula for that? Theta upon 360 into pi r square. R is given, theta is given. You have to just calculate it. And fourth one they were given, area of PRXS. That is the area of the major sector. So do you have to calculate again? Do you have to use this formula again? No, because in second sub question you have already found out the area of circle. Now you have found out the area of this sector. Just subtract and you will get the area of this sector. That means area of this sector can be found out by two methods. Whatever method is simple for you, you just use that method. For example, area of circle minus area of this sector is area of the remaining part. Very simple thing. Okay, let us go ahead. The radius of a circle is 7 centimeter. Find the area of the sector of this circle if the corresponding angles, now they are given for different angles. First angle they are given is 30 degrees, second angle 210 degrees, and third is 3 right angles. Now in this case, radius of the circle is given 7 centimeters. These angles are changing for 30, 210, and they say 3 right angles, means 270 degrees. One right angle is of 90 degrees, so 270 degrees. And so you can find out area of sectors from this information. You have to use this formula. Every time radius will remain same, only the theta will change, the calculation work will change, and you can easily find out that. Fifth question they are asked, an arc of a circle having measure 36 degrees has a length of 176 centimeters. Theta is equal to 36 degrees. L, length of an arc, is 176 meters. Find the circumference of the circle. Now here in this case you don't have to use any of these formulas. Why? Because do you remember how we derived the formula of length of arc? Length of arc means circumference for particular degree. So I can say for 36 degrees the length is 176 meters. So for 360 degrees, what is the length? 360 into 176 divided by 36, that is 1760. You don't have to use any formula in this case. Very simple. So your answer is 1760 meter. That is the circumference of this particular circle. Let us go ahead. An arc of length 4 pi centimeter, L is given, is equal to 4 pi centimeters, subtended an angle of 40 degree at the center. So your theta is equal to 40 degrees. Find the radius and the area of the sector formed by this arc. You have to find out the radius and area of this particular sector. Extremely simple. There is nothing in this. You have to use first this formula to find out the R, and then you have to use this formula to find the area of that particular sector. Don't get puzzled or don't get fooled by this pi. This is just a figure. Okay, this is just a figure. Use this pi. This will get cancelled somewhere else. During the calculation, this pi will automatically get cancelled. Okay, don't get confused that a particular number is not given and that length is given in terms of pi. Okay, it's just to confuse you. Okay, let us go ahead. Problem number 7. Very simple. If the area of the minor sector is 392.5 centimeter square, area is given 392.5 centimeter square, and the corresponding central angle is 72 degrees and theta is equal to 72 degrees. Find the radius. Extremely simple example. You have to just substitute in the formula. Area is equal to theta by 360 into pi r square. Only r is unknown. Just mathematical calculation. Please pause your video and solve this example. Example number 7. You have to just substitute in the formula. Area is equal to theta by 360 into pi r square. When you solve this, you will get r is equal to 25. Of course, unit is centimeter. Please check your answer. Let us go to example number 8. Now in this case, you have to use the different formula. We have already seen this formula. Find the area of sector whose arc length and radius are 10 centimeter and 5 centimeter. So they are given the length of arc is 10 centimeters and radius 5 centimeter. Now in this case, this is also direct substitution of formula. This sum appeared in March 2015 for 2 marks. Very simple. Area is equal to r upon 2 into length of arc. I hope you remember this formula. Extremely simple. When length of arc and the radius are given, area can easily found out. Please pause your video and solve this. Area is 25 centimeter square. Let us go to example number 9. Now these examples are very simple, are the direct substitution of formula. I don't think that I need to solve these examples on the board here. I am leaving it to you. Just we will read and discuss. If the area of minor sector of a circle with radius 11.2 centimeters is 49.28 centimeter. Radius is given, area of minor sector is given, find the measure of the arc. Now only theta is unknown. Now you know the formula for area, that is area is equal to theta by 360 into pi r square. So just substitute in the formula and you will get an answer. 10th example is find the length of the arc of a circle with radius is 0.07 centimeter. Now in this case radius is given and the area of sector 0.49 meters square. Radius is given 0.7 meters and at last the area of the sector 0.49 meters square. You know, just now we have seen that the area of sector is equal to r by 2 into length of arc. So just substitute in the formula and you will get an answer. Next example, 11th example is two arcs of the same circle have their lengths in the ratio of 4:5. Now the lengths are in the ratio. So I can say L1 L2 is the ratio 4:5. So if L1 is equal to 4x, I will say L2 is equal to 5x. Now we know the formula. Now we have to find out the ratio of their areas. So what will be the ratio of areas? A1 upon A2 is equal to R upon 2 into L. Now same circle means radius is same. So it is R by 2 into L1 and R by 2 into L2. Now R by 2 will get cancelled and ultimately A1 upon A2 is equal to L1 upon L2, that is 4x upon 5x, x will get cancelled. So ultimately A1 and A2 are also ratio in 4:5. Very easy example. So such kind of example, whenever the ratios are there, you should be very careful. Just check whether they are given the length of arc are in ratio or radius are in ratio, and accordingly you have to substitute in the corresponding formula. Easy example. Let us go ahead. Example number 12. The figure depicts a racing track. Now here they are given the figure. The figure depicts a racing track. That means the figure is given. We'll draw the figure in short while. But sometime it may happen that they will give only a word problem. Figure is not given in the paper. So in that case, you have to draw figure by the given description. So let us try to draw figure with given description. Okay? Whose left and right ends are semicircular. Racing track is there. Now this is a racing track. You know, you might have seen the Olympics and all those games where the racing tracks are always semicircular at the end. Okay? So the racing tracks are semicircular. The distance between two inner parallel line segment is 70 meter and they are each 105 meter long. Now these are the semicircles. That means here we have a line. Now this distance is 70 meters and this is 105 meters long. Correct? Now we are trying to draw the figure by given description. Okay? If the track is 7 meters wide, width of the track is 7 meters wide, that means this is exactly similar figure will be there at this end, and this distance is 7 meters. Okay, so this line I can extend these lines. Actually this example is very simple, okay, but I am taking this example in detail here because you should be able to draw the figures from the given descriptions. Okay, don't think that always the figure will be given. Specifically in trigonometry. In trigonometry, the figures will not be given always, and you have to draw the figures with the given description. So here we have drawn the figure with given description. Then find a difference in the lengths of inner and outer edge of the track. We have to find a difference between the length of the inner and outer edge of the track. That means we have to draw the perimeters. We have to find a circumference of perimeters. That means this circumference plus this length. Now this length is again 70 meters. Now how can we do this? This is very simple example actually. Let us solve this example. Starting from here, we have to come back to this position. Obviously this is 105. Okay, we have to find a circumference of this, half circumference, then plus this and plus this. What is the radius? 35. And what is the circumference? Is 2 pi r. For the inner track, what is the circumference? What is the perimeter? Is 105 into 2 plus 2 into 2 pi r, that is pi d by 2. 2 into pi d is 70, pi into 70 upon 2. So quickly calculate, this is the inner track, and what will be about outer track? This distance is same, so we have 105 into 2 plus, now what is the diameter? 70 plus 7 and 7, 14, that is 84. 2 into pi into 84 upon 2. So again, very simple calculations, and ultimately what we have to find? The difference between lengths of the track. That means final answer our is difference is equal to, this is P outer, PO minus PI. So please pause your video and solve these two and find out PI and PO, and at last the difference. Please pause your video and solve this example. The final answer you might have got is 44 meters. This is the final answer. I have given you the final answer, 44 meters. But I have not told you about perimeter inner and perimeter outer. Why? Now this is the perfect method. That means the length of the track. But there is a smart method too. You see one thing, if these lanes are 105, why we should calculate this? We will not calculate at all, because this is also 105 into 2, 105 into 2. So first calculate, then subtract, no use. Correct? Next thing, so here we are given 2 into pi d. Correct? Now in this also, can you see that this is also not required, because on the both the side it is same. Now here this is also not required, because division is by 2 on the both the sides in the both the expressions. So if I take only these figures, I will get the difference. So now it is PO minus PI. What is PI? What is PO? Pi into 84, and PI is pi into 70. You might have calculated these all, but this is the simplest thing. Now pi is common, so it is pi into 84 minus 70, that is 14. And if I take pi, 22 by 7 and 14, 7 2s are, and it is 44. Correct? That means I have avoided all the calculations in between. If you want to measure the complete perimeter, have they asked? If they have asked what is the outer perimeter and what is the inner perimeter, then you have to calculate this. But they have asked only the difference. So all these calculations are not required. If you have done the calculation, you might have got the same answer like me. But this is the smart thing. This is the smart way of solving this. Okay, you can just write down that for the inner circle, the perimeter of the circle, because these are on the both the sides, so this becomes the complete circle. Correct? This half circle and this half circle, both the sides, so it is a complete circle. So perimeter is pi d, which is this, and in the inner circle or in the outer circle, the perimeter is again pi d, is this. So there is a difference, where the difference is coming only on the circular path. Correct? So this is the fastest and smartest method to solve this example. I have taken this example specifically because I knew that how we are going to solve this example. Again I am telling you, there is no harm, absolutely no harm, if you go in the thorough way. But if only difference is to be calculated, then no need to go in the thorough way, because difference is there only in the circular way, not on the straight path. There is no difference of length in a straight path. Understood this? This is very simple. This is only to teach you that whenever you get a problem, don't directly start solving it. For 5 seconds, just think over it. Can this be solved by any simpler method, any smart method? Can some of the calculations be avoided? Now, here in this case, I could have taken here itself 22 by 7, then 220, because 7 tens are 70. Here 220, and again here some calculations, and then subtract. But instead I saw that pi is common, so why should I waste my time and energy in calculations first? So this is how we are going to solve the examples. Let us go for the next example. Example number 13. Now, just like previous example, in this example also the figure is given, but still we will try to find and try to draw the figure with the help of the description. So what they say, a horse is tied to a pole fixed at one corner of 30 meter by 30 meter square field of grass by a 10 meters long rope. That means initially there is a 30 meters by 30 meters. This is 30 by 30, 30 meters by 30 meters, a square grass field. Okay, the horse is tied to a pole fixed at one corner. That means the pole is fixed here. The pole is fixed here. Horse is tied to a pole with the rope length is 10 meters, 10 meters long rope. Now suppose the 10 meters long rope is there and a horse is tied. Okay, we will see the maximum stretch of the rope is 10 meters. The horse can move only in the circular direction, the rope circular direction. So the horse can graze in this area of 10 meters radius circle only. Correct? What they ask? Find the area of that part of the field in which the horse can graze. That means we want to find out this area. This sector we have to find out. Very simple. You know that radius is 10 and what is the theta? Theta is 90 degrees because it's a square. So area of sector is theta by 360 into pi r square. So just substitute and find out the answer. The second part of example is, what will be the area of the field in which the horse can graze if the pole was fixed at the middle of the side? That means now the pole is fixed at the center here, and now the rope length is same 10 meters, but now the horse can graze in this semicircle of radius 10, and now you have to find out in what area the horse can graze. Extremely simple. Here there is a semicircle, pi r square is the area of circle, pi r square by 2 is the area in which the horse can graze. Very simple example, this also, but in this case the figure was given. But always whenever you have a word problems, try to draw figures without looking the figures in the book. Even though the figure is given in the book, don't look at that figure. By your word problem, try to draw your figure and then match if you have drawn that particular figure perfect or not. This will give you practice of drawing figures from the description. Okay, and that is what important. If you miss the figure, if the figure is wrong, your sum is 100% going to be wrong. So the calculation part of this is very, very simple. Even I don't think I should give you formula and show you the expression here. So please pause your video and solve this example. The answers are In this case, it is 78.5 meters square, and here 157 meters square. These are the answers. Please check your answer. Calculation work for such a simple examples, don't miss the calculations. Okay, you will unnecessarily lose the marks. This example may come for 3 marks. Okay, here we have finished the exercise 6.1. Now we'll move to next topic. Thank you.